This video is on simplifying rational expressions. Recall that a rational expression is a fraction whose numerator and denominator are polynomials. Since division by zero is undefined, the polynomial in the denominator cannot equal zero. The values of the variable that make the denominator equal zero are called excluded values. We say that a rational expression is simplified when the numerator and the denominator have no common factors other than 1. To simplify a rational expression, we want to factor both the numerator and the denominator and divide out any common factors. Let's take a look at several examples here. We need to simplify each rational expression and state the excluded value or values of the variable. So the first one is a polynomial 25 x to the fourth y to the third minus 15 x to the third y squared plus 5x squared y to the third, all divided by 5x squared y to the third. So notice that my denominator is not a polynomial, it's actually just a monomial. So the easiest way to do this is to write this as 3 fractions. So 25x to the fourth y to the third over 5x squared y cubed minus 15x cubed y squared over my denominator, and my last monomial in the numerator divided by my denominator. And now we're just going to simplify each one of those. So that becomes a 5. And then I have x to the fourth over x squared gives me x squared. And y to the third over y to the third cancels out. So this rational expression simplifies to 5x squared. Minus, and then here this will simplify to 3, and then an x, and leave me with a y in the denominator. So 3x over y. Plus, notice that my numerator and my denominator are the same. That doesn't necessarily go away. That is actually equal to 1. So simplified, I have 5x squared minus 3x over y plus 1, which I guess technically isn't a polynomial since it has a variable in the denominator. Excluded values of the variable. Go back to your original unsimplified version, and x cannot equal 0. And y cannot equal 0. So those would be my excluded values of the variables. Second example, 2 minus x divided by x squared minus 9x plus 14. So I really don't like the look of 2 minus x. I usually prefer to see something that looks like x minus 2. So I'm going to do a little work over on the side here. So 2 minus x is actually equal to negative x plus 2. And I don't usually like having a negative out front, so if I were to factor out a negative 1, that's going to be equal to negative 1 times x minus 2. And I think I'm going to write it that way as I write it here. So negative 1 times x minus 2. And then I have to factor my denominator. So that's going to factor into x minus 7, x minus 2. And now I can cancel out some common factors. There's a common factor of x minus 2 on the top and the bottom. So that's going to leave me with, I think I'd like to write it like this, negative 1 over x minus 7. That's simplified. Now to get my excluded values, I'm going to go back to my original factored denominator. So my original denominator was x minus 7 and x minus 2. And that cannot equal 0, so that means that x cannot equal 2 and x cannot equal 7, because both of those values of x would make my denominator equal 0. And my last example here is 21 minus 3n over n squared minus 49. So again, I think I'm going to rearrange this because I don't really like the look of that. I'm going to write that as negative 3n plus 21. And when I factor out a negative 3, I'll get an n minus 7. So I think I'm going to go ahead and do that. So negative 3 times n minus 7 My denominator is a difference of squares, so that's going to give me an n plus 7 and an n minus 7. So I notice that I have a common factor of n minus 7, so I'll cancel that in the numerator and the denominator, and that leaves me with negative 3 over n plus 7 is my simplified rational expression. And going back to my original factor denominator for my excluded values, n cannot equal a positive or negative 7. So in this video, we took a look at how to simplify rational expressions. Rational expressions basically being fractions with polynomials in the numerator and the denominator. Don't forget that before you cancel anything out, before you find any common factors, you actually do have to factor both the numerator and the denominator if possible. Look for your excluded values. Those are going to be the values of the variables that make the denominator equal to 0.